So today, first of all, topic, it is actually a Common Core. It stands for F for functions, IF, which is interpreting functions, and section 4. So what does it say? The Common Core says we're going to interpret functions, key features of its graph. All right? We're going to try and do a lot of it with the calculator. That's always kind of nice, right? And of course, part of the trick is knowing how to use a calculator. But I'm going to go through it slowly with you. Question 1 isn't going to take a calculator at all because calculator 1, the graph is here. So let's take a look at the graph. This is super easy. Please pay attention, because every time I do this every year, some kids are like, I don't get no savings. I go, well, just watch. And then they listen finally, and they go, oh, that's easy. So, t of 1. So you get a 1, and the answer is the height. It's the height at 1. 25. It's that easy. Here's a 1. The answer is the height. Here's the t. So at 1 hour, what's the temperature? 25. That's it. T of 3, go to 3. What's the corresponding height? It's about 30. Yeah, it's that easy. T of 0, about 15. Yeah. Okay, there's nothing hard about that at all. Yeah, super easy. But wait, somebody will say, Mr. Davies, I don't get it. Hopefully not. Cross my fingers. Okay, now, for which value is t increasing? So when is t increasing? From what hours? From what to what hours? From 0 to 2. You guys agree with that? So we'll use interval notation. We'll go from 0, comma to 2. How's that? Okay. Where is it decreasing? Well, right at 2. 2 to about 6, maybe even 7. We'll say 7. So we'll go from 2 to 7. Okay. Now let me ask you a question. At 2, is it increasing, is it decreasing, or is it just at the top? So at 2, you're at the top of the hill. Are you going up or are you going down? You're at the top of the hill. You're right here. Are you going up or are you going down at the top of the hill? You're not really doing either. So you know what we do? We kind of change this. So it is increasing from 0 to 2, but when you're at 2, you're at the top hill. I know for we Lucky Track kids, when we run the hill, when we're at the top of the hill, we're no longer going up. Does that make sense? When we're at the top of the hill, we're no longer going up. We're just at the top hill. When we're going down the hill, we start at the top. We don't start going down until we start going down. So I use my parentheses because at 2, I'm neither going up nor down. I'm at the top. Does that make sense? So then, what's the local max? That's easy. It's at 2. And what is that? About 35? Now that's a point. That's a point. So we have to be careful that we don't misinterpret interval notation with points. 235 is a point. That's the top of the hill. That's my local max. Okay, what's the net change from 1 to 3? So from 1 to 3. Let's see. So at 1 o'clock, what is the height of the temperature at 1?
25.
25, right? And what's the temperature at 3 o'clock? 30. Okay, so we went, in a sense, up 5 degrees, didn't we? Now, of course, it had some stuff in between, but the net just means, what had happened from 1 to 3. And let's just say it's as simple as this, since we are stuck inside all day. We could take the temperature at 1 o'clock and we could take the temperature at 3 o'clock. We don't really know what happens in between. We would say that the temperature went up by 5, right? That's it. All right? Okay, number 2, solve the following graphically, all right? Now there's 2 ways to do this. I could do this algebraically. I could, okay? And I'm pretty good at algebra. You might have to factor it and solve it. But it says graphically. So I'm going to go through this slowly, I promise. I'm going to graph both of these equations in my calculator. I'm going to graph both in my calculator. Where they intersect is where they're equal. Does that make sense? Where the lines intersect is where they're equal. So if you haven't used a graphics calculator for a long time, let's go ahead and go through this slowly, okay? So everybody have one? Okay. Turn it on. All right. Go to y equals. See my y equals button right here? Y equals. If we go to y equals, right there, y equals. Okay, clear out whatever's there, clear. Okay. And then I'm going to go 2x squared plus 3. Okay. The x variable is here, right? 2x variable. And I use my little squared button. Screw it up a little bit. The little squared button is down there. Plus 3. Okay. Thumbs up if you got it. I want to make sure. Okay. If you don't have it, I'm waiting. I want to be real patient. We got 32 kids in here. 30 kids in here. I want to make sure I go through this slowly. Zane. Oh, yeah. So if you're in the wrong mode, hold on real quickly. Mode. Mode's got to look like this. Let's go to the mode. I hit the mode button. Your mode has to look like this. Great question, Zane. So last semester's pre-calc kids were doing a different kind of mode, okay? So your mode's got to look like this, okay?
There we go.
Did you get it? And then try it again, okay? So your mode's got to look like that. Yeah, you gotta go to mode. Okay. Everybody have it in function mode? So it's really important. We're talking about functions, aren't we? This whole chapter, our entire chapter is about functions. So we've got to have our calculator in functions. Some of you guys had it in parametric, and some of you had it in polar. We're not going to talk about that until June. Okay? So y equals. Okay, and I'll wait for you. Everybody good on that? And then the second equation I put in, which is my 5x plus 6. Okay?
I'm trying to make sure.
Yeah, now, the window is really important. So, the window, before I do a whole lot with the window, let me write it down. So, a normal window would probably be negative 10 to 10. Does that make sense? I'm thinking about a normal graph. When I graph negative 10 to 10, normal graph. So, my window, let's just go negative 10 to 10. That's like a normal graph, right? So if I go, back 1, 2, 3, 4, my graph, 1, 2, 3, 4, right? Negative 10, 10 makes sense, right? And the same thing on my y's. Let's do my y's be negative 10 to 10 also. So this is my x's, and my y's will be the same thing. Scales by 1, negative 10 to 10. Okay, does that make sense when I do the scale, do the window? Yeah. Negative 10 to 10, because I'm doing a normal graph, right? Normal graph, negative 10 to 10. Okay, now let's push graph. See the graph button? Okay, you ready? Graph. Okay. Everybody have that? Anybody not have this picture? Okay, Lane, you got it?
Yes.
Okay, now, I have an answer. Right about, see where I'm looking? Right about there is the answer. I want to solve for x. Right about there, okay? So, the way I find this is I'm going to go to calculate. So I'm going to go to second calculate, okay? It's in blue. Second calculate. Went to blue calculate, okay? Everybody went there? And I want to go to intersect because I want to find out where they intersect, okay? So I'll write this down, okay? I'll write it on the board. So I went to second calculate, right? And then I'm going to go to intersect. Okay, and so push enter. Now it's going to ask me first curve, second curve. So I have a little cursor on my back and forth arrow keys. I can kind of move them around. See, move them around. But I really want to get it pretty close to. I want to get it close to my point of intersection because it's saying, okay, where do they intersect? Well, I think just about there. You guys okay? Just about there. So it's blinking. It's a cursor. It's blinking, right? When I finally decide where I want to put it, try and put it right where they intersect, right? It's blinking. When I want to lock it in, I push enter. So I just push enter, it locks it in. Okay. Now second curve. Do not push the up and down arrows. Don't push the up and down arrows. Push the back and forth. Don't push the up and down. Say it 3 times. Don't push the up and down arrows. Push the back and forth. Okay? Everybody got that? Hope so. Okay, push the back and forth. Okay, so now I got to get it close. Oh, it looks like about there. It's blinking. I got it right where I want it. If I push enter, it locks it. Okay? Now guess. You don't have to guess. The people that made this calculator made it for students. It's a teachable moment. I'd say, Naomi, where do you think the intersection? You'll say, I think it's right about there. I'd say, you're probably pretty much right. So you don't need to guess. Just push enter. And there's your intersection point. Now we're solving for x, aren't we? We're solving for x. So what's the answer? Negative 0.5. So the answer is x equals negative 0.5. Yes, but would you believe me if I said there's a second place that they intersect?
What?
Now, if I look at my graph, it's
Oh.
going up.
There's a one going.
There might be one further up. Might be one way up there, right? So how do I do that? If I go to my window, now let's be smart about this. I think there's another. If I go to my window, and I want to look further up, I want to look farther up, what am I going to change? I'm going to go look further up. What am I going to change? My Y max. I want to change my Y max. Instead of being at 10, a height of 10, let's go to what? Let's go to 20. 15 might work. 15 might work. I would have to over-guess, Alondra.
Okay.
So then I have to go back and do it again, right? So 15 might work, by the way. Let's try 20. Okay. Is not enough? Okay. Elijah says not enough. So graph.
Like 30.
Okay. Not enough. Okay. So I heard 30. Okay. Let's go to window. Let's go a little higher. Let's go to 30. 40 would work probably, right? So being over, shooting over is never a bad thing. Does that make sense? Graph. Right?
So it's 40?
30 works. 30 works. Okay. So I see it. So how do we do this? We go to second calculate. We're going to go second calculate, right? We're going to do this. Go to intersect, right? Intersect. Enter. First curve, I think it's not there anymore. I got to take this little cursor back. One more time. Back and forth arrows, not up and down. Back and forth arrows, because you're moving it along the x-axis. That's why it slides up. Okay. Right about there. What do you think? Right about there. Okay. Push enter and it locks it in. Right. The other second curve, yeah, it's right about there. Push enter. Guess. I don't need to guess. So what's the x value? I'm solving for x. 3. Okay, x equals 3. Okay, there we go. Now, I'm going to do myself a little favor here just because I know what's coming. I'm going to do a little graph. I'm going to graph what it looked like. It looks something like this. All right, and it looks something like this. Okay, got it. This is at negative 0.5, and this was 3. Okay, do you see my little picture? It's going to help me answer the next two, okay? So if I draw a picture, this is going to help me draw it, okay? All right. This is my 2x squared plus 3, and this is my 5x plus 6, okay? So I kind of know where I'm going with this because I'm the teacher, right? So by drawing a picture, I can answer the next question, okay? So, everybody listening? When is the parabola greater than the line? Or when is the parabola above? When is the parabola above the line? Because this is greater than. Well, the parabola's above the line here and here, right? In these two areas. So the answer to this would be when x is greater than or equal to 3. Because at 3, the parabola is greater than the line. At 3, the parabola is, and when x is less than or equal to negative 0.5. So the question says, when is the x when is the parabola greater than the line? In this region and in this region. When x is greater than 3 and when x is less than negative 0.5. Does that make a little sense?
Yeah.
Okay, kind of shaky, thumbs up, sideways thumbs. Okay, good. Now let's look at the next graph, okay? So the next thing says, when is the parabola less than the line? So when is the parabola less? So when is the parabola below the line?
Between 0.5 and...
Right. So I could write it in a couple of ways. I'm going to write it in 3 different ways. So when x is greater than or equal to negative 0.5, or when x is less than or equal to 3, right? But you could write that as one statement. I don't know if you remember this from algebra or whatever, but I could write it as negative 0.5 is going to be less than or equal to x, which is less than or equal to 3. Okay, that's one way to write it. But if you hate that, you remember interval notation? Or, I like this. This is the easy way to write it. That's interval notation, which I think is easier. So it says it's between negative 0.5 and 3. That is when the parabola is below the line. When the parabola is less than the line. It's not that bad, is it? Okay. All right. Thumbs up. Okay, let's turn the page. All right. Example 3. So we're going to have to sketch. So, and find the domain and the range, find the zeros, find the intervals and increasing, decreasing, find the local mins, local max. If the function is defined between negative 3 and 4, find the absolute maxima and minima. Holy smokes, that's a lot to do. But you know what? Let's put it on the calculator, okay? Let's make it easy. So go to y equals, right? Clear, clear. Okay. 12x squared plus 4x cubed. Now do the cubed and go to the power of 3. That's my little caret thing. To the power of 3. Okay, little caret thing. Minus 3x to the power of 4. Okay, got that? I'll wait for you, okay? So if you want to raise it to a power, you have this little button here.
Okay.
This little button here. You guys see it? Raises it to a power, okay? Okay. Everybody good? Now, on my window, let me move this aside for a second. On my window, I only want to look at the graph between negative 3 and 4. That's it. I only want to look at so I want to look at only from negative 3 to 4. That's it. So what I'm going to do on my window is only go from negative 3 to 4. And all the rest of the graph, I don't care about. So I'm just going to say I only want to look at this chunk of the graph. Okay? Kind of like our reading. Remember when I chopped it off in our reading? And we had that weird squiggly graph?
Yeah.
Yeah. I mean, I want to do the same thing. I want to chop it off, so I only want to look at it between negative 3 and 4. So I made sure I only went from negative 3 and 4. Window, you want to go from negative 10 to 10 for right now, and then if we have to play around with it, we can, okay? So, let's graph it and see what we get, okay? Ready? Say graph.
Whoa.
Okay. All right. Now, it looks like I'm missing something, doesn't it? Doesn't it look like I'm missing something? So way up there, I got to go further up. How high do you think we got to go? 100? Okay.
50.
Okay. How about 50? 50 might be good. 100 wouldn't be bad, because to judge over. Okay. Naomi says 50 is going to work. Okay. There you go. Oh, 50 works nice. Okay. So I see a local max, a local min, and a local max, right?
And our absolute max.
Yeah, and an absolute max, exactly. So I'm pretty sure, and it's going to look something like this. We don't have to have a perfect sketch of it. It just has to have the right shape. So it looks something like this, okay? And again, it doesn't have to have the perfect shape. It looks something like this, okay? Just want to sketch it down. I'm pretty sure 0, 0 is a local min, right? So a local min, I'm going to put my local min, I'm pretty sure I've got 0, 0 as a local min. Would you agree with that? Right at the bottom, right? Bottom of the hill. Local max, all right? We can get those. We know how to get those, right? Oh, you know what? You don't know, but I bet we could figure it out. Check it out. So what button do you think I'm going to push? Second. Calculate. And guess what we're going to find? No!
4.
How about a maximum? How about a max? Because we want to find the top of the hill, right? So let's go to maximum. Okay, so I'm going to go down to my max. Boom. So now I've got 2 maximums, right? So I have to be careful to tell the calculator where. Now it's saying left bound. Let's find the little one first. So to be the left bound, I got to be on the left-hand side. So I'm going to try and tell the calculator where to look. So I'm going to take my cursor and put on the left-hand side of the top of this hill. So right about now I'm at the top of the hill, okay? I'm going to go to the left of it. I'm going to go a little bit further over. It doesn't really matter how far over, just as long as I give the calculator a region to look. I need to give the calculator a region to look. So it said left bound, so I took my cursor and put it on the left-hand side of my hill. It's blinking. I push enter, locks it in. Right bound, okay. I want to go the right there at the top of the hill. I go to the right-hand side of my calculator, right? It's blinking. I push enter, locks it. Now check this little arrow stuff out. See this little arrow thing here, right here? It's telling the calculator, look here, by the way. Calculator, look here. And the reason you want to do that is because you don't want it to look over here, do you?
No.
You want to look right in there, right? So guess. You don't have to guess. If you want to go there, you can say, I calculate. I think it's right there. Let's see what you get. Here it is. So it's about -1 and 5. So we have a local max at -1, 5. All right. So local max at -1, 5. Okay, I'll put that dot in there. -1, 5, and this is 0, 0. Okay, got it. So far, so good? Okay, now let's go and take a look at our other max. We got another max, right? How are we going to get our other max?
Second.
Okay, second calc. Maximum, right? Enter. Okay, I want the big hill now, right? I want the big hill. Take it over, all the way over. Okay, we want a left-hand bound, so I just have to be on the left-hand side. Does that make sense? Left-hand side of my hill, I'm there. It's blinking. I'm going to push enter, locks it in. Okay. Right-hand bound. Right there. Enter. Okay. Lock it in. Okay. It's 2 and 32. Okay. So if I take a look, I've got a local max at 2, 32. Okay. How am I doing? Good so far? All right. Now zeros. Zeros. Okay, that's a 0, that's a 0, and that's a 0. Zeros are where it crosses the x-axis. Zeros are where it has a height of 0. It's called a 0 because what's the height? 0. What's the height? 0. What's the height? 0. Now we already know one of the zeros is 0, 0. You agree with that?
Yes.
So guess what? We can find the zeros on these too. Guess what we're going to push? What do you think? Just take a wild guess. Second
Cow.
calc. Let's see what we get. Yeah, zeros, right? Second calc. Hey, it's got a 0 button, right? Pretty cool. Enter. So now, it sure looks to me like I have a 0 way over here. So let's see if I can find this 0. So it says left bound. Listen carefully. The left side, this point right here, is really above it. Does that make sense? This, if you're going to be the left, this point's really above it. So I have to just go left-hand side. So I'm going to bring the cursor over here. That's to the left-hand side of it. Yes, it's above it, but it's left of it. Okay. It's blinking. Push enter, locks it. Now I'm going to go underneath it because I have to find the other side of the 0, right? So go underneath it. Okay. I push enter. Now it tells the calculator, look right in here. Look in this little space, and you'll find the 0, right? Okay, guess. I don't really care about guessing. Anyway, enter. So there's my 0, about 2.77. So my 0 is about 2.770. And then we got another one, right? Okay. All right, so I'm going to go to calculate 0. Let's go all the way over to the other side of the graph and find the other 0. I'm not going to find the 0, 0. I know that's a 0, 0. I know it for a fact. Oh, I wish I could see a little bit more of my graph. Don't you?
So we could go into Windows and change it.
My min. Let's change I'm going to change my min to -20 so I can see more of it, okay? There we go. How's that? I can see a little bit more of it. Second calculate. 0. Okay, now I got to go over there somewhere. Left-hand bound. So the left-hand bound would be under it. Does that make sense? The left hand of it would be under it because that's the left-hand side of it. So this point now is left of it, right? It is left of it. Enter. Right-hand bound would be above it because it is the right-hand side of that. Enter. Guess. You don't have to guess. Okay, and I get about a -1.44. So my other 0 is a -1.440. Okay? Now, there's 2 more points I need. Okay, 2 more points. I need to know, you ready? I'll do this in another color. I need to know this point here, and I need to know this point here, right? Because I'm looking at it only between -3 and 4, okay? Which point's lower? Do you know? Okay, here's another easy way to find this, okay? One more time. I'm not going to go second calculate. I'm going to go to trace. I'm going to hit trace. Hit trace. Everybody hit trace, the trace button right there. And I want to look at -3. So if I go -3, I'm going to trace, enter. So this one's way down at -243. Too much to graph, right? So I know this point is at -3, -243. And this button right here, I'm going to hit my trace, and I'll go 4. Okay, 4. And it's at -320. So I've got a point at 4, comma, -320. Which point's lower? You guys agree? So, you ready? What's the absolute max on this graph? Absolute max on this graph.
32.
2, comma, 32 is my max. Right? That's the very highest point. What's my absolute minima?
Negative.
4 and -320. Okay? Last thing. We're almost done. Okay? Increasing. When is it going uphill? It's going uphill from here to here, isn't it? Isn't it? So it's going uphill from, so increasing, it's going uphill from -3 to -1. From an x value of, yeah, I'm sorry you guys, yeah. So it's going uphill from -3 to -1. Does that make sense? From this x value to this, and it's also going uphill somewhere else, isn't it? Is it also going uphill from 0 to 2? Is it going uphill from 0 to 2? And from 0 to 2, it's going uphill, right? Where's it going downhill? Yep. So it's going downhill, or it's decreasing from -1 to 0. And where else? 2 to 4. And it does go from 2 to infinity, does that make sense? But we are stopping at 4, right? So also from 2 to 4. Okay? So it's a big lesson today. Big key about this whole lesson, though, is